Okay, so good afternoon, basically. So everybody watching, my name is Learning Start, and I'm a final year statistics student of University of Ibadan. So I I, I decided to do this. What's it called? This do a YouTube explanation on this question. I got this question from a friend from University of Calabar, I think so. So I decided to do a YouTube video on this. Okay, so this is a very like funny enough, the question looks very very small, but the question is it's kind of like crazy, but at the same time, it's simple. Okay. So now the question says, suppose that X has a PDF given by this. Okay. And the PDF is 1 over 2x plus 1, and the range is -1 less than x less than 1, 0 otherwise. Obtain the MGF E of x variance of x. Okay. So the first question there is we should obtain the MGF. Okay. Now, if I am to obtain the MGF of this PDF, the MGF The MGF is given as expectation of exponential Tx, right? This is what we define the before we do that, it is the MGF is mx of t, okay, and it is given as expectation of exponential Tx. Now, in this case, this guy is a continuous PDF, right? So since it is a continuous, therefore, I'm going to be integrating from -1 to 1 of exponential tx dot f of x dx. Okay, so that would be integral -1 to 1 exponential tx dot, what is my f of x? This is my f of x, which is 1 over 2x plus 1 dx. Okay, so from here I can say 1 over 2 integral -1 to 1 exponential tx, sorry, let me just, x exponential tx plus exponential tx dx. So continuing from here, I can say 1 over 2. Now I want to integrate this. I want to integrate x exponential tx. So I'm going to use integration by part. Okay. And if I use integration by part, I'm going to have x over t exponential tx minus 1 over t square exponential tx. That is the integration of this one. Plus the integration of this one will give me 1 over t exponential tx. Right? So from here, I have 1 over 2. Let me make this together. I have x plus 1 over t exponential tx minus 1 over t square exponential tx. 1 minus 1. Okay, so I have 1 over 2. 1 over 2 exponential tx into bracket x plus 1 over t minus 1 over t square. 1 minus 1. So now I can substitute my upper limit minus my lower limit. So that is substituting 1 anywhere I see x minus substituting -1 anywhere I see x. So that would be exponential t into bracket 1 plus 1 is 2. So I have 2 over t minus 1 over t square close bracket minus, now substituting -1 anywhere I see x will be exponential negative t into bracket -1 plus 1 is 0. So that is, I'm left out with this one. That's -1 over what? T square close bracket. That's 1 over 2 Um, okay, so for me, I can say 2 exponential t. That is, using this exponential t to expand, I have minus exponential t over t squared. Minus times minus, we have plus exponential negative t over what? T squared, close bracket. Okay, so I can say 1 over 2 into bracket, take the LCM, that's t squared, right? So I'm going to have 2t exponential t minus exponential t minus exponential negative t, right? Now, this t square can come out. I'm going to have 1 over 2 t square over, and then I'm going to have 2t exponential t minus exponential t minus exponential negative t. Okay, so at this point, what we can do is you see, okay, yes, I can just decide to simplify and say 2t square into bracket exponential t 2t minus 1 minus exponential negative t. Now, this is my MGF. This is my MX of t. That's it. Therefore, my MGF, which is what? MX of t is equal to what? 1 over 2t squared into bracket exponential t 2t minus 1 minus exponential negative t. This is my MGF. Now, question number 2 says E of x. E of x simply means your expectation of x. E means expectation. So E of x simply means expectation of x. So expectation of x, remember that expectation of x is our mean. So E of x, now anytime you have your E of x, anytime you have to look for your E of x, your E of x simply means the first differentiation of your MGF when you set t to be equal to 0. That is m prime x of what? Of 0. That is, I'll take my MGF and differentiate once. And after differentiating, anywhere I see t, I'll put 0. Now let's apply it to this guy. Remember our MGF. Remember our MGF is what? Our MGF is this. That is ET 2t minus 1 minus exponential negative t over what? 2t squared, right? This is my mx of t. So what I can say is I'm going to differentiate this guy. M prime x of t. Now, if I differentiate this guy, I'm going to have 2t squared into bracket. So I'm going to have 2 exponential t, right? Plus et 2t minus 1 plus exponential negative t minus, okay, yes, minus 4t into bracket exponential t 2t minus 1 minus exponential negative t all over what? 4t raised to power 4, using your quotient rule, your normal quotient rule. Now, if I do m prime x of 0, you will notice that I'm going to have, when I set t to be equal to 0, I'm going to have 0 at the denominator. And anything over 0 is what? Undefined or infinity, right? So now this problem is, how do I get my my expectation of x, which is my mean? Now what we can do is, instead of using this method, what we can basically do is, since this method is not valid because a direct substitution of 0 here will give us an undefined answer, what we can do is I can use the Maclaurin series. Okay, now, and how do I do that? Since I need my Since I need my expectation of x, what I can do is I will have to start again from my MGF. And remember, my MGF is what? My MGF is what? Expectation of what? Exponential Tx, right? This is my MGF. Now, remember that from Maclaurin series, if we say exponential lambda, it will be what? 1 plus lambda square over 2 factorial plus lambda 3 over 3 factorial plus dot dot dot. Therefore, exponential Tx will be 1 plus Tx plus Tx all squared over 2 factorial plus Tx raised to power 3 over 3 factorial plus dot dot dot. Right? Now I'm going to, this is expectation of exponential Tx and this is exponential Tx. Therefore, I can say expectation of exponential Tx is equal to expectation of everything here. That is 1 plus Tx plus Tx squared over 2 factorial plus Tx raised to power 3, 3 factorial plus dot dot dot. Right? Now I'm going to be expanding using my rule of expectation. So that will be expectation of 1 is what? That is 1. Because expectation of a constant is a constant, right? Now, expectation of Tx will be T expectation x. Remember that expectation of constant x is constant expectation x. So the same thing applies here. T is a constant, so T will come out. We are left out with expectation of x plus this one. We are going to have c square over 2 factorial expectation x square, right? For this one, we are going to have c3 over 3 factorial expectation x raised to power 3 plus like that, right? Now, this is what I'm going to do from here is I am going to look for expectation of x. That is this one. I'm going to look for expectation of x squared. And I'm going to look for expectation of x raised to power 3. Right? Now, so let me look for expectation of x first of all. Expectation of x will be integral from -1 to 1 of x, f of x dx. And that is integral -1 to 1 of x. What is f of x? This is my f of x. That is 1 over 2 x plus 1 dx. Right? So I'll have to clean this part and continue. So remember that we are looking for my e of x, and where we stopped was integral -1 to 1 x dot 1 over 2 x plus 1 dx. So this is 1 over 2 integral -1 to 1 of x squared plus x, right, dx. So this is 1 over 2. Now, if I integrate, I have 1 over 3 x raised to power 3 plus 1 over 2 x squared. That's 1 minus 1. That's 1 over 2. So upper minus lower, I'm going to have 1 over 3. That's 1 over 3 plus 1 over 2 minus the lower one. I'm going to have minus 1 over 3 plus 1 over 2. Right? So that is 1 over 2. So from here, what I'm going to have is 2 over 3, which is what? 1 over. Therefore, my expectation x is what? Expectation x is what? 1 over 3. So I'm going to do expectation x squared. Expectation x squared. My expectation x squared will be integral -1 to 1 x squared f of x dx, right? That will be integral -1 to 1 x squared 1 over 2x plus 1 dx, right? So that will be 1 over 2 integral -1 to 1 x raised to power 3 plus x squared dx. Now, if I integrate, I'm going to have 1 over 4 x raised to power 4 plus 1 over 3 x raised to power 3. So this will be 1 over 2. Sorry, that will be 1 over 2. So if I do upper minus lower, I'm going to have 1 over 4 plus 1 over 3, right? Minus 1 over 4 minus 1 over 3. That will be 1 over 2. Then this will be 2 over 3, that, which is 1 over 3. So my expectation x squared is what? 1 over 3. Now I'm going to do expectation x raised to power 3. So that will be expectation x raised to power 3 will be integral negative 1 to 1 x raised to power 3 dot f of x dx, which is integral negative 1 to 1 x raised to power 3 dot 1 over 2 x, sorry, yes, 1 over 2x plus 1 dx, which is what? Which is 1 over 2 integral negative 1 to 1 x raised to power 4 plus x raised to power 3 dx. That is 1 over 2. Now, if I integrate, I'm going to have 1 over 5x raised to power 5 plus 1 over 4x raised to power 4. Sorry? 1 minus 1. This is 1 over 2. So, upper minus lower will be 1 over 5 plus 1 over 4 minus, I'm going to have 1 over 5. Sorry, this is negative 1 over 5. Yes, 1 over 5 minus 1 over 4. So this will be 1 over 2. This will be 2 over 5, right? 2. Sorry, this will be positive rather. Yes, positive. So this will be 2 over 5. So this will be 1 over 5. Now, I have gotten my e of x. I've gotten ex squared. I've gotten e of x raised to power 3. So what I will do is to come here to this place and substitute. That's what I'm going to do. Okay. So now, remember that this is my expectation e exponential tx. So remember what I said. I'm going to come here to that place and substitute each of these guys. This one, this one, this one. I'm going to substitute it into this one. So that will be expectation exponential tx. That will be what? Remember, it is 1 plus t exponential x plus t square over 2 factorial exponential x square plus t raised to power 3 factorial exponential expectation x raised to power 3 plus dot dot dot. That will be 1 plus t. What is expectation x? 1 over 3. So that will be 1 over 3 plus, that will be this will be t squared over 2 factorial. What is expectation x squared? That's 1 over 3 as well. 1 over 3 plus t3 3 factorial. What's x raised to power 3? 1 over 5. 1 over 5 plus dot dot dot. Right? So this will be 1 plus c 1 over 3t plus 2 factorial is 2. So that's 1 over 6 2 square plus 3 factorial is 6 times 5 30. That's 1 over 30 t raised to power 3 plus dot dot dot. Therefore, this is my what? This is my MGF. That expectation exponential tx is my MGF. Therefore, mx of t is what? 1 plus 1 over 3t plus 1 over 3t plus 1 over 6 t square plus 1 over 30 t raised to power 3 plus this. This guy is my MGF. Okay. Now, in this case, for me to get my expectation x will be very easy. All I have to do, remember that for me to get my expectation x, all I have to do is just to take the MGF and differentiate. I have to differentiate the MGF, and anywhere I see t, I'll set it to be equal to 0, right? So I. Remember, I'm using another method now. So expectation x is m prime x of what? Of 0. That is, I differentiate the MGF, and after differentiating, anywhere I see x, sorry, anywhere I see t, I'll set it to be equal to 0. So that will be, so first of all, let's do m prime x of t. So if this is my mx of t, but I want to do m prime x of t, so I have to differentiate this infinite series. So differentiation of 1 is 0, so that is, differentiation of this one will be 1 over 3, right? Plus this one will be what? 2 over 6, which is 1 over 3t, plus this one will be 3 over, that will be 1 over 10c squared, plus dot dot dot, right? Now remember that my mean is m prime x of 0. That is, anywhere I see t, it will be equal to 0. Now if I put t, that's 1 over 3 plus 1 over 3 0, sorry, plus 1 over 10 0 square. This one will be 0, this one will be 0. I have what? 1 over 3. Therefore, expectation x, which is my m prime x of 0, is what? 1 over 3. That is, my mean is equal to what? My mean is equal to 1 over 3. Right? Now, the last question there says, find the variance of x. Find the variance of x. So if I'm to look for the variance of x, which is question number 3. Now, we know that variance of x is what? Variance of x is m prime prime x of 0 minus the square of what? M prime of 0. So now, remember that I've gotten my m prime x of 0, which is 1 over 3. M prime x of 0, 1 over 3. All I have to do is to get m prime prime x of 0. Right? So, same thing. All I have to do is take this MGF and differentiate twice. Then set it to be equal to 0. Or take the first differentiation and differentiate again. Okay? So, what I'll do is, I'll just take this first differentiation and differentiate again. So, remember that m prime x of t is what? 1 over 3 plus 1 over 3t plus 1 over what? 3t plus 1 over 10c squared. Therefore, m prime prime x of t will be 1 over 3 plus 1 over 3 plus 1 over 5c. So, m prime prime x of 0 will be 1 over 3 plus 1 over 3 plus 1 over 5, 0. Now, this one will become 0 here. Everything becomes 0. So, this one I have 2 over 3 as my final answer for the m prime prime x of 0. Okay. So, finally, all I have to do is, since my variance is equal to, since variance of x is equal to m prime prime x of 0 minus the square of m prime x of 0. What's m prime prime x of 0? 2 over 3. That's 2 over 3 minus m prime x of 0, 1 over 3. That's 1 over 3 square. So that is 2 over 3 minus 1 over 9. And if you solve that, we should have 9. So we have 6 minus 1. I have 5 over 9. So my mean is 1 over 3. My mean is 1 over 3. And my variance is, my mean is 1 over 3. And my variance of x is what? 5 over 9. Okay. So thank you very much and thank you for watching.